Are you smarter than a medieval student? Well, let's take a look at this school textbook from the year 1478 to find out. This is the Treviso Arithmetic, and it was the first printed arithmetic textbook in Europe. The Treviso Arithmetic was written for students in Italian Abaco schools. This was a 2-year course, typically for boys aged about 11 to 16. They were mostly the sons of merchants, shopkeepers, artisans, and clerks. They were being prepared for trade, bookkeeping, commercial travel, and city administration. Treviso was a city in northern Italy, part of the trading networks connecting Venice to the rest of Europe. Trade routes passed through it, bringing goods like cloth, spices, sugar, and metals. The word abaco comes from the Latin abacus, but abaco schools were not actually teaching the bead frame calculations. Instead, they taught algorism, which was calculation using the Hindu Arabic numerals written on paper. Addition, subtraction, multiplication, division, fractions, currency conversion, interest, profit sharing, and algebraic problems written in words. Students were learning the kinds of mathematics needed to convert currencies between cities, calculate profit on cargo, divide business partnerships, and measure debts and interest. In other words, the math of everyday capitalism. We do not know who wrote the Treviso Arithmetic because it is anonymous, and no author's name appears in the book, and none is known from records. But the copy I have here was translated into English by Frank Swets in 1987. Together with his commentary, this volume of the book is titled Capitalism and Arithmetic. Taking a look inside the textbook, we see this is a scan of a real untranslated page where the owner has scrawled their name, Marco Bellarami. 450 years ago, Marco was probably sitting in class doing the exact same exercises we're about to try. The book is structured like a curriculum full of repetitive exam-style problems. There's a multiplication table, reminder of addition, subtraction, multiplication, and division, and examples of how they work. You'll see the words lira, soldi, and ducats. These are some of their coins. Let's take a look at some questions. First question, if 1 yard of crimson is worth 5 ducats, what will 85 yards be worth? This one is very easy. I think you can solve it. Remember, no calculators. I would write it like this, just as they've done. 5 times 5 is 25 and carry the 2. 8 times 5, well, we can check the table if we want. It's 40. So 425 ducats. This is a merchant trader example. Crimson cloth was expensive dyed fabric, often imported. Similar questions on this page involve trading silver and saffron. Second question. If 100 pounds of sugar are worth 32 ducats, what will 9,812 pounds be worth? The hardest part of this is they don't use decimals, so we will need to convert the answer to use smaller coins, a combination of ducats, grossi, and pizzoli. There are 24 grossi in a ducat and 32 pizzoli in a grossi. In the solutions, they do 32 times 9,812, then divide by 100. They get 3,139 ducats, and then 84 is the remainder. These 84 are reduced to grossi first. 84 100ths of a ducat times 24 is 2,016 hundredths, or 20 grossi with 16 remaining. 16 hundredths of a grosso times 32 is 512 out of 100, and that's 5 with 12 remaining. And that final 12 over 100 is left as a remainder. That simplifies to 3 over 25. So the final answer is 3,139 ducats, 20 grossi, 5 pizzoli, and 3 25ths. In my last video, I covered the Liber Abaci by Fibonacci. A couple of 100 years earlier, it introduced to Europe the Hindu Arabic numerals and new computational methods. The Treviso Arithmetic shows what happened after that knowledge spread and became normal classroom mathematics. An anonymous publication was not unusual for school books of this period. because it was not a display of originality, it was a practical teaching manual written to be used, not admired. But importantly, this book was printed, and that tells us a lot. The printing press had only arrived in Europe about 30 years earlier. Printing a textbook only makes sense if there are a lot of students learning the same material. That tells us that Abaco schools were somewhat widespread, standardized, and economically important enough to warrant the cost of printing. Third question. I have 9 yards and 2/3 of cloth, 2 yards and 3/4 wide, which I wish to make into a garment. I wish to line this with cloth 1 yard and 1/8 wide. How much do I need? I would draw 2 rectangles to understand that we want to find the area of the first cloth and then divide that by the width of the lining to find the unknown side, which is the length of the lining. We get 2,552 out of 108. The author actually made a mistake here. That's a tricky fraction, but merchants would have memorized a lot of multiplications, including up to 25 or 30 times tables. They could quickly find that it's between 24 times 108 and 23 times 108, and subtract the difference. It's 23 and 68 out of 108, which divides by 4 to give 23 and 17 over 27. A trained merchant could do calculations like that probably quite quickly in their head. Since these students were often the children of merchants, they would commonly attend school only part-time while working in family businesses. Teachers demonstrated methods, then students copied and solved similar exercises repeatedly. There was no formal exam system, but finishing the course meant you could work as a merchant's clerk or apprentice. Fourth question. A hare is 150 paces ahead of a hound, which pursues him. The hare covers 6 paces, while the hound covers 10. Required is to know how many paces the hound has made when he overtakes the hare. So the hound gains 4 on the hare every time he takes 10 steps. 150 divided by 4 is 37.5, so it will be 375 steps. Fifth question. 3 merchants have invested their money in a partnership, whom, to make the problem clearer, I will mention by name. The first was called Piero, the second Polo, and the third Zwain. Piero put in 112 ducats, Polo 200 ducats, and Zwain 142 ducats. At the end of a certain period, they found they had gained 563 ducats. Required is to know how much falls to each man so that no one shall be cheated. For each one, we'd want to do 563 multiplied by their investment out of 454, which is the total invested. This big pile of numbers with things struck out is them doing a division. They're choosing a trial digit, multiplying it and subtracting to see what the remainder might be. They want to know how many times does 454 go into this big number on the top. You can read it as trying multiples of 454 until one fits. Here are the 3 parts of the solution to this problem. Later in the book is another illustration of that kind of division. It's also called galley or scratch division. And maybe this is the first doodle seen in a maths class. There's also the first printed example of modern long division, done a different method. This is 53497 divided by 83. And all of this sits in the middle of a bigger intellectual debate at the time. There was a rivalry between 2 camps, abacists and algorists. This illustration shows the spirit of arithmetic presiding over a contest between them. Abacists use the counting board, or abacus, and algorists use numbers and algorithms. The abacists had the advantage of speed, at least initially when these written calculations were still new. A trained abacus user could add or multiply extremely quickly by moving beads. There were also fewer writing or copying errors. The algorist methods came from Indian and Arabic mathematics and spread into Europe through scholars like Fibonacci. Instead of moving beads, you wrote numbers on paper. Not everyone embraced it straight away because it broke from the familiar and trusted methods. Also, paper was expensive. Here's another illustration describing it as a computing controversy. But the algorist method offered an audit trail and a record of the entire calculation, making trades easier to track, and it was easier to learn and master than an abacus board. You could stack columns, carry digits, work with fractions, solve algebraic problems. And once that method spread, mathematical literacy suddenly became accessible to many more people. Merchants might once have hired specialists to do calculations for them, but with written algorithms, they could learn the skills themselves. Abaco schools were where this new mathematical literacy was taught. So why are they called Abaco schools if they taught algorithm? Well, because the word abaco gradually came to mean practical arithmetic, even when the abacus itself wasn't being used. So, would you pass an abaco school exam? These students trained intensely for about a year or two. They memorized tables and solved hundreds of problems by hand. Medieval math class didn't include calculus because that hadn't been invented yet. That would come in the late 1600s. I used the equal sign in some of my working for these questions, but that wasn't introduced until 1557, and the multiplication sign not until 1631. At the time of this medieval math class, there were also no logarithms, no coordinate geometry, and no probability theory. If you think these questions look too easy, just remember you've had the benefit of 500 years of refinement in how this mathematics is taught. Students like Marco Bellarami didn't. Over those centuries, we've slowly discovered something important. Maths is much easier to understand when you can see it and interact with it, instead of just memorizing rules from a page. That's why I like today's sponsor, Brilliant. Brilliant teaches math and science in a very different way. Instead of watching lectures, you actually solve problems step by step, interacting with the ideas as you go. You're not just reading formulas, you're playing with them. For example, their course on coordinate transformations visually explores some of the ideas that are super useful to us now, but didn't even exist yet in medieval classrooms. Today, mathematics is much more than just merchant arithmetic. It's a language that unlocks the world. It's a foundation of science, engineering, computing, and understanding nature. If you want to try Brilliant yourself, you can learn for free for 30 days at brilliant.org/Tibees, and Brilliant is offering my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. So if you're curious to explore maths in a much more interactive way, scan the QR code on screen or check it out at the link below. Thank you to my Patreon supporters for making my videos possible. On the screen now are the names of patrons who have joined at the Gold tier. And a special shout out to today's Patron Cats of the Day, Autumn and Junie.